published instrument procedures. Loading an IFR approach is easy, and once you've done it a few times, it takes about 5 seconds. You must have an IFR airport as the active waypoint in order to activate an instrument approach. Press the Active button. By this time, you should be realizing that virtually anything involving waypoints in your flight plan is done with the Active button. Choose the airport, choose IFR Approach. Choose the approach, then the transition, then the runway. It's just that simple. To activate a Vectors to Final approach, press the Active button. Choose the airport, choose IFR Approach, choose the approach, choose VTF, then the runway. An extended final approach course and the final approach fix will be drawn on the map, and ATC will vector you to intercept it. On the moving map, a discontinuity in the course line will precede the final approach course. Setting up a departure procedure is done in a similar manner. Push Active and choose the departure airport. Choose DP, then the transition, then the departure runway. The waypoints of the DP will be inserted into your active flight plan. Only pilot navigation DPs are available in the Efis. Only eligible runways will be selectable. If a minimum climb gradient is required, set it in the VNAV climb angle as described earlier. To set up a standard terminal arrival route, push Active and choose the destination airport. Choose Star, then the transition, then the runway. The star waypoints will be inserted into your active flight plan. If you do not know the runway yet, just pick one because it only affects which runway is highlighted. It does not affect the route drawn on the map. If you then activate an IFR approach, it will be appended to the end of the star. Procedurally, once you have activated an approach, you should verify the crossing altitude for each waypoint. Push the Active button, scroll to each waypoint, and review the crossing altitude shown for each. Calculated altitudes are shown in magenta. Target altitudes are white. Note that minimum altitudes at the missed approach point are not provided by Jeppesen in the database. Always set the minimum descent altitude or decision height when setting up for an approach. These will be obtained from current approach plates. Then, set the decision height or minimum descent altitude by pushing Menu, then Bugs, then pushing Min Alt. Use the knob to set the desired altitude and push to enter. Verify the missed approach procedure waypoints and altitudes in the same manner. As you fly a flight plan or procedure, the active waypoint will usually be sequenced automatically as you pass each waypoint. Under certain circumstances, however, automatic waypoint sequencing is suspended automatically. This happens upon passing the final approach fix and when in holding patterns, including holding pattern course reversals. You may also manually suspend automatic waypoint sequencing by setting a Manual GPS OBS course. An advisory flag reading Suspend will be shown in the lower left corner when automatic waypoint sequencing is suspended. To re-enable waypoint sequencing that has been suspended automatically on approach, push Missed inside the final approach fix. Pushing Missed will arm the missed approach procedure, and it will automatically be activated upon passing the missed approach point. It is good practice to push Missed as soon as it appears. Automatic waypoint sequencing is also suspended in a holding pattern with additional waypoints after it. When in a holding pattern, push Continue when you wish to leave the holding pattern and fly to the next waypoint. The Efis will draw this continuation from the holding fix. VFR approaches can be depicted to any runway or user waypoint. For a VFR approach, push Active. Choose the airport or user waypoint, choose VFR Approach, and then choose the runway. All runways at the destination airport will be shown, but the usable portion of the one you select will be highlighted in light gray on the PFD and moving map. The VFR Approach function does not guarantee terrain separation, so it must only be used in VFR conditions. It is very useful, however, for locating the airport and correct runway, stabilizing approaches, and preventing over or undershooting the runway on black hole approaches during VFR at night. Selecting a VFR approach at non-IFR airports will also desensitize the TAWS alerting functions to help minimize false alerts. VFR approaches can also be activated for any user waypoint with a defined final approach course, providing precise approach guidance to any point, anywhere. Note that VFR runway ends are not surveyed, so data is not available for them in the Jeppesen database. VFR runways are based on the official airport reference point, which may or may not be on the runway. Consequently, the depiction of VFR runways may not coincide with what you see out the window. High-altitude jet routes and low-altitude Victor airways are easy to enter into the Efis either during flight planning or by using the Active menu to add them to your existing route. You can add an airway to the end of your route or insert it in the middle. To enter an airway, it must be preceded by a fix that is on the airway, like a VOR or an intersection. You cannot add an airway between airports because airways don't include airports. Airways are identified using their name, like V113 or J54, and are entered in the same way they are received in a clearance from ATC. Imagine you are departing the Boise Airport and receive the following clearance.
ATC clears November 885 Charlie to Salt Lake City Airport. Fly runway heading after takeoff. Vectors to join Victor 253 to Twin Falls, Victor 142 to Shear, Victor 101 to Ogden, direct.
Since the Boise Airport is not part of Victor 253, we will have to start with the nearest VOR, or fix on the airway. In this case, the Boise VOR is located on the airport, so we enter that as our first waypoint. Push the nearest button and use the control knob to choose VOR, then BOI. Now, push the Active button and scroll to the empty space after BOI and choose the Add button. Use the control knob to enter a V for Victor Airway. Here, you can either spell out V253 or push the knob to step through the blank spaces and be presented with a list of all airways running through the Boise VOR. Choose Victor 253 and scroll up or down to the desired endpoint on that airway, the Twin Falls VOR in this case. Repeat the process to continue entering the clearance. The airway route will be drawn using VORs and turning fixes. Other fixes along the airways are eliminated to simplify the active route. Finally, use the same procedure to add Salt Lake City as the destination. Push Active, scroll to the end of the waypoint list, press Add, enter KSLC, and push to enter. Jet routes are entered the same way by using a J instead of a V. Let's review. Flight plans and user waypoints are created and edited using the Flight Plan button on any screen but the pilot's PFD. Flight plans may be created and stored using the Flight Plan button or created on the fly by adding waypoints in sequence. Editing an active flight plan doesn't affect the stored copy of the flight plan. Use the Active button to perform functions on the active flight plan, such as activate VFR and IFR approaches, or change the active waypoint. VFR approaches are for use in VFR conditions only. IFR approaches can be entered as an entire procedure or as vectors to final. Push Missed to arm the missed approach procedure after you pass the final approach fix. You can go direct to any waypoint in the active flight plan by using the Direct To button from within the Active menu. The active waypoint is indicated by an asterisk. Use the Active button to enter airways. Use V for Victor Airways and J for jet routes. Airways must begin with a fix or VOR on an airway. Use the Active button to add and delete waypoints in your active flight plan or to review the waypoint sequence and get waypoint information. To set a Manual GPS OBS, push OBS, choose GPS, and turn the knob to set a course. This is very useful for flying non-published en route holding patterns. Just set up the inbound course and fly into it each time around. Use the green lubber line to make sure your outbound leg is parallel. Automatic waypoint sequencing is suspended when a manual OBS course is selected. To turn off the Manual GPS OBS and return to automatic waypoint sequencing, push OBS, then choose Auto. The OBS mode is indicated next to the CDI on the PFD. A is for automatic, M is for manual. Use the OBS button to set the navigation source driving the HSI display on the PFD or MFD. This can be set to GPS as just described, or NAV1 or NAV2 if the Efis is interfaced with VHF nav receivers. This way, any course can be selected to or from any waypoint or VOR. Just push the OBS button and choose NAV1 or NAV2. Turn the knob to set the OBS as desired. The HSI source will always be displayed as an advisory flag in the lower left corner. The Skyway boxes are 320 feet high and 400 feet wide. By comparison, a localizer at the inner marker is 700 feet wide. The boxes are spaced every 2,000 feet along your route. For a course change of more than 5 degrees, they bank in the direction of the turn. They do not indicate a target bank angle. 5 boxes, 2 miles worth, are always shown ahead of the aircraft, so you have 2 miles of anticipation prior to a turn. For en route turns, the boxes create a turn radius based on 15 degrees of bank at the aircraft's speed. During approaches, the boxes create a turn radius based on 15 degrees bank at the VPROC speed programmed during installation. If you fly faster than VPROC, your bank angle will have to be steeper to maintain the turn radius, and vice versa if you fly slower. Flying the Skyway is like driving down the road in your car. You see a turn coming and you turn with the road when it turns. On straight sections, you make tiny corrections with the steering wheel to stay in your lane. Fly the Skyway the same way, but don't worry if you drift outside of it, especially in turns. Remember, it is half the width of the localizer just prior to the runway. The CDI at the bottom of the PFD is your primary navigation cue, but if you are anywhere near the Skyway boxes, the CDI will be nearly centered. Note that, unlike conventional CDIs, this one provides deviation indication through turns. Apply small control inputs to guide the flight path marker through the boxes. Use tiny corrections, as if on a localizer, for straight segments. The nature of the flight path marker eliminates the need to compensate for winds. For turns, fly wings level until you pass through the last level box preceding a turn, at which point you bank 15 degrees in the direction the boxes are turning. Adjust the bank angle during the turn to account for the effects of wind. If you drift outside the turn indicated by the boxes, increase your bank angle. If you are turning inside, reduce your bank angle. It is helpful to overlay the moving map's projected path on the course line to determine the correct bank angle. Soon you will be able to do it using the Skyway alone. Likewise, use the projected path when intercepting the Skyway at a steep angle until you can do it with the Skyway alone. If you ever lose track of the Skyway, refer to the magenta line on the moving map and keep in mind that the boxes may be above or below you based on your target altitude. The FlightLogic Efis provides advanced digital roll steering to your analog autopilot using the AIU. It does this by emulating the heading and course signals generated by a mechanical HSI. When your autopilot is in heading mode, it receives roll steering in the form of a heading signal from the Efis. Roll steering is based on GPS course or the Efis heading bug. The Efis heading bug overrides the flight plan course. Roll steering is like you using the heading bug to steer the aircraft. With this method, the Efis can lead your autopilot laterally through any procedure. The HSI source determines what is controlling your autopilot when it is in the nav or approach mode and is receiving a course signal. With this method, the autopilot performs as it always has, using ground-based navigation signals like a VOR or ILS. This greatly simplifies use of the autopilot. For a flight that ends in a non-precision approach, simply put your autopilot in heading mode after takeoff and let it follow the highway in the sky for the entire flight. the Efis and autopilot will automatically perform all lateral navigation hands-off. Use the heading bug to override the course if you receive a vector from ATC. You will have to control vertical navigation of the autopilot traditionally, although the Efis will provide you with the altitudes to enter into your preselector. For a precision approach, activate the approach as previously described. Set the HSI source on the Efis to the nav radio that is tuned to the ILS. Scroll to Done with the control knob and push Enter. The HSI will automatically be displayed on the Efis. Push Nearest, choose ILS, choose the desired ILS, and push Course Sync, and the HSI will automatically be set to the final approach course. Or you may select the course by pushing OBS and turning the control knob. Push Enter when finished. Prior to the final approach fix, switch your autopilot from heading mode to nav or approach mode. Your autopilot will capture the ILS localizer and glide slope signals for a coupled approach. The Efis will guide your autopilot through the entire procedure hands-off. At the decision height, if executing a missed approach, just put the autopilot back in heading mode and initiate a climb in the normal manner. The Efis and autopilot fly the entire missed approach laterally hands-off. All you have to do is control the vertical navigation. For vectors to final, configure the Efis as previously described. Your autopilot should already be in heading mode from your en route procedures. Leave the autopilot in heading mode and follow the vectors given by ATC, using the Efis heading bug to intercept the final approach course. If the heading bug is turned off, the Efis will intercept the final approach course automatically. Leave the autopilot in heading mode for a non-precision approach. On an ILS, place the autopilot in nav or approach mode prior to reaching the final approach fix as described earlier. Use the approach checklist on the laminated quick reference guide to ensure you have properly configured the equipment for an approach. Due to the wide variety of autopilots supported and their varying techniques for intercepts in nav mode, the AIU supports intercept angles up to 135 degrees when driving the autopilot in nav mode. For optimum intercept performance, leave the autopilot in heading mode and let the Efis intercept automatically, or use the Efis heading bug to bring the intercept angle to 135 degrees or less before switching to nav mode. The Efis heading bug overrides all. If you use the heading bug to alter a course temporarily when receiving vectors for traffic, for example, the Efis will automatically re-intercept your course when you turn the heading bug off. Let's review. The GPS CDI is your primary reference for navigation. The Skyway traces the magenta course line on the moving map. Flying the Skyway will keep the CDI centered. Use small control movements when flying the Skyway. Banking Skyway boxes indicate an upcoming turn. Track your progress in turns using the projected path on the moving map. When your autopilot is in heading mode, it will fly the Highway in the Sky flight plan or the Manual GPS OBS course. The heading bug overrides the flight plan or Manual GPS OBS course. When your autopilot is in nav or approach mode, it is controlled by the HSI source, which is enunciated in the lower left corner of the screen. Use the approach checklist in the quick reference guide to make sure you have properly configured for the approach. Intercepts in nav mode are supported up to 135 degrees. Use your autopilot heading mode for all DP, en route, star, and approach procedures up to the final approach fix. Just prior to the final approach fix, simply switch your autopilot to nav or approach mode and your autopilot will fly the ILS. At the missed approach point or decision height, put the autopilot back in heading mode and establish a climb. If connected to an autopilot with Flight Director capability, the Efis will display the Flight Director command bars on the PFD as a dual Q centered on the flight path marker. The dual Q method is used on the Efis because it is the recognized standard for displaying Flight Director in conjunction with HUD symbology, as used on the PFD. The vertical line represents the roll command the autopilot is sending to the roll servo, and the horizontal bar represents the pitch command being sent to the pitch servo. The Flight Director is giving the pilot cues to act as the servos. When a bar is displaced from center, it indicates that a pitch or bank input in that direction is required. Apply the appropriate input until the needle is centered. Then neutralize the controls and hold that attitude until the needle moves off center again. Remember, the flight director is nothing more than a pictorial representation of servo commands. The Efis allows you to set a variety of bugs in addition to the heading bug, including target and minimum altitudes and a variety of airspeeds. To activate the heading bug, push the heading button. Turn the control knob to set the heading and push to enter. The heading bug can be set on any screen. All other bugs can only be set on the PFD screen. To set a target altitude, push the Menu button, push Bugs, push Target Alt, enter the desired target altitude, and push to enter. This will override any existing VNAV altitude. To turn the target altitude off, push the Menu button, push Bugs, push Target Alt, and push Off. Follow the same procedure to set a minimum altitude, target airspeed, or climb speed. Similarly, to set takeoff V speeds for jets, push the Menu button, push Bugs, and push V speeds. Use the control knob to choose Takeoff. You will be prompted for V1, VR, V2, and VENR in turn. Use the control knob to enter the speed and push to advance to the next one. These speeds are automatically decluttered with the exception of VNR when exceeded by 40 knots and the aircraft is above 2,000 feet AGL. They are reset to 0 after each flight to prevent inadvertently using an incorrect speed for the current takeoff weight. Set approach speeds in a similar fashion. Push Menu, then Bugs, then push V speeds. Choose Approach and follow the prompts to enter VREF and VAP with the control knob. Use the Bugs menu to set VNAV climb and descent angles. Push Menu, then Bugs, and then push VNAV CDA. Use the knob to choose descent angle or climb angle and set the desired angle. Push the knob to enter. Timers are provided for count up, count down, and elapsed time since takeoff. To start a count-up timer, push Menu, then Timer. Using the knob, choose Count Up and push to enter. The timer will be displayed on the PFD above the flight path marker and on the MFD under the Zulu time. For Count Down, choose Menu, then Timer. Using the knob, choose Countdown. Enter a time using the knob or increments of plus 5 minutes and push to start the countdown. Push Store if you wish to preload the countdown time for later use. A chime will signal the expiration of the countdown timer. Elapsed time since takeoff can be displayed by pushing Menu, then Timer, then choosing Flight Time using the knob. It will be displayed for 10 seconds or until another button is pushed. An airspeed switch starts the flight timer during your takeoff roll. Controlling the appearance of the displays is easy. To scale the nav display moving map, traffic, and lightning displays, just turn the control knob. Turn it clockwise to increase the scale. To zoom the PFD view, choose Menu, then Zoom On. To return it to the standard view, choose Menu, and then push Zoom Off. In the normal mode, the PFD's field of view is similar to that of a wide-angle camera lens. This is most useful for the majority of flight operations, since aircraft maneuver primarily in the horizontal plane. It does, however, diminish the visual impact of terrain. The zoomed mode most closely matches the field of view of the human eye, and therefore makes the terrain display more closely resemble the real-world view ahead of the aircraft. This zoom setting is useful for landings, as the runway depiction is expanded. The PFD's field of view is indicated on the moving map by the dashed gray lines that form a pie shape ahead of the aircraft. Objects within this pie shape will appear on the PFD. To set the map orientation, choose Menu, then Format. Then use the control knob to choose North Up or Heading Up. North Up is useful for aligning the moving map with an approach plate or taxiway diagram to get your bearings. To display the dedicated traffic or lightning screens, choose Menu, then Function. Then use the control knob to choose Traffic for the traffic display or Strikes for the lightning display. On either of these displays, the active flight plan may be shown as well by choosing Menu, then Format, then using the knob to choose Route On. To format the moving map as an arc or centered in the compass rose, choose Menu, then push Format, then choose Arc or Center. To display a conventional HSI on the MFD, choose Menu, then Function. Using the control knob, choose HSI. To go back to the moving map, choose Menu, then Function. Using the control knob, choose Map. Push to enter. Both the PFD and the moving map may be manually decluttered according to pilot preference. To add and remove symbology from the PFD, choose Menu, then Declutter. Use the control knob to enable and disable features. A check mark means it is enabled. Select Done when you are finished. The moving map has an auto declutter mode that limits the total number of elements displayed on the screen. Elements are removed based on level of relevance versus the scale. As you increase scale, IFR fixes are the first items to be removed. At the maximum scale, only large airports are shown. The pilot may override the auto declutter mode and specify items to be displayed all the time or not at all. Victor and jet routes, traffic, lightning, airspace, borders, lat long, and more may be shown at the pilot's discretion using the Manual Declutter feature. On the moving map, choose Menu, then Format. Use the knob to choose Function Declutter, and then use the knob to enable or disable items, including high and low airways. Select Done when you are finished. Manual declutter settings will be retained when the Efis is powered down. Depiction of large airports, IFR airports, VORs, fixes, and more can be controlled by choosing Symbol Declutter. Choose the Menu button, then Format. Use the knob to choose Symbol Declutter. Push Enter. Choose Manual. Items that have been selected will have a check mark. Select Done when you are finished. When turned off by the pilot, traffic and terrain will turn on automatically if a threat is detected. To check the status of any device connected directly to the Efis, choose Menu on the MFD, then push Faults. An X indicates a fault for that device. As you now know, the Flight Logic Efis uses a variety of sensors to generate flight information. Failure of these sensors, singularly or in combination, will degrade the functionality of the Efis, but it will not render it useless. For example, in the event of a failure of the air data computer, all functions relying on air data will be removed from the screen, but attitude display and navigation functions will be unaffected. The manner in which functionality is degraded is determined by the failed sensor. The best way to become familiar with these effects is to run the ground training application in your aircraft and refer to the sensor failure matrix in the pilot's guide near the end of Chapter 3. Plug a PC keyboard into the Efis keyboard port in the cockpit. Run the ground training application as described earlier. Pressing 1 through 7 on the keyboard will generate various failures as identified in the failure matrix. Press 0 to restore all components. Time for another quick review. Bugs may be set for target altitude and minimum altitude, heading, and airspeed. VNAV angles are also set under the Bugs menu. Timers can be set to count up and down. Elapsed flight time can also be displayed. Many aspects of the displays are pilot configurable, including scale, function, format, and declutter mode. System failure modes can be simulated and studied using the ground training mode and the pilot's guide. Failure modes and associated pilot actions are also covered in the Master Caution System Training Aid described earlier in this program. By this point, you should have a basic understanding of the Efis and its capabilities. Now, we'll make a series of sample flights and show every single button push that is required to complete each flight. Long legs with no activity have been edited for length. You can fly these flights using the ground training mode in your aircraft. Let's start with a basic VFR flight. Power up the system and verify the database coverage and currency. Set Fuel Totalizer on MFD. Push Info to get the local frequencies for airport information, ground, and tower. Note that the altimeter is set automatically. It may differ a few hundredths from the recorded pressure due to many variables, but it will prevent you from accidentally setting it an inch in error. Push the Direct To button and enter the destination using the control knob. A waypoint hoop will be placed at the destination airport, and Skyway boxes will generate a turn toward it. If the waypoint is displaced beyond the edge of the PFD, a magenta arrow on the directional scale will point toward the waypoint symbol. Once airborne and headed in the right direction, you may recenter the course line by pushing the Direct To button and then pushing the control knob to enter. As you begin flying with the Skyway, make sure the bank scale on the PFD is set to Auto Declutter. Do this by choosing Menu, then Declutter, then unchecking Bank Scale and choosing Done. The bank scale will automatically declutter below 2.8 degrees of bank. Now, if you see the bank scale come on while you are hand-flying the Skyway, you probably have too much bank and will S-turn along the course. It rarely takes pilots more than 5 to 10 minutes of practice to get the hang of it. Adjust the scale of the moving map to a comfortable setting by turning the control knob on the MFD. Note that this is the only operation in which a turn of the knob is not followed by a push. While you are on the moving map, note that a single push of the control knob brings up the reversionary PFD. Another single push and you return to the moving map. Refer to the waypoint information box below the minimap for bearing and distance to the waypoint, which in this case is the destination. As you approach the destination airport, push the Info button to access runway and frequency information. When you identify the runway in use, activate a VFR approach by pushing Active. Then use the control knob to select the destination airport. Choose VFR Approach and select the active runway. The course in the map and the Skyway will depict an extended final approach course from an initial point labeled IP to the touchdown zone. Since the Efis doesn't know where you intend to intercept the final approach course, the IP is preceded by a discontinuity in the course line. Use the lubber line and projected path to fly a nice square pattern and smoothly intercept the final. On the PFD, the Skyway will provide guidance for a stabilized approach at the current VNAV descent angle setting. During the approach, set pitch and power so that the flight path marker is in the smallest box. Note the 500-foot AGL callout as you descend.
500, 500.
As you reach short final, the runway becomes visible. Position the flight path marker on the runway threshold. This will result in a stabilized approach and a touchdown in the first third of the runway. Prior to shutdown, note the total flight time by pushing Menu, then Timers, and then use the control knob to select Flight Time. No special precautions are necessary for shutdown. Simply turn the power off. Now we will make a basic IFR flight with a departure procedure and a GPS approach. Begin this flight the same way as the last one by accessing the airport information. Push Info for ATIS, clearance delivery, ground, and tower frequencies. This time, we'll create and store a flight plan. Push Flight Plan on the MFD or reversionary PFD and use the knob to choose Create Edit. Use the knob to choose Create New Flight Plan. To add the departure airport, push Add, and then use the control knob to enter the identifier. Enter at least 2 characters. You may, but are not required, to enter the leading K. In this example, we'll enter RNO for Reno, Nevada. Use the knob to select the one you want. Note that symbols next to the identifiers distinguish airports, VORs, fixes, and so on. Repeat the procedure to add additional waypoints until your flight plan is complete. In this example, we'll enter SAC for the Sacramento VOR, then KVCB for Nut Tree, California. Push Save Exit when you are finished. The route will be saved and automatically named using the first and last waypoints. Duplicate routes between the same airport pairs will be automatically appended with a number so you can store multiple routes between them. You can activate the flight plan from here now, or wait until later and activate using the Flight Plan button on either the PFD or MFD. To activate it now, use the knob to scroll to Activate Flight Plan, and push to enter. Use the knob again to choose the flight plan. The list of stored flight plans will be alphabetized. Now that you have the flight plan loaded and you know the departure runway, load the departure procedure by pushing Active, then choose the departure airport. Then choose DP. Then choose the desired procedure. Then choose the proper transition. Then the departure runway. The system will prompt you for each entry. Now, set the required minimum climb performance if one is specified on the plate. Push Menu, then Bugs, then VNAV CDA. Use the knob to choose Climb Angle and set the minimum required angle or feet per nautical mile. The WAGI 2 departure from Reno does not have assigned altitudes. These will be issued by ATC in a clearance. Note that some DPs don't list altitudes for fixes, even though they have a minimum climb angle. In this example, the minimum climb performance is 370 feet per nautical mile. To set assigned altitudes for VNAV planning, push Active. Then scroll through the departure waypoints with the control knob. Dashed magenta lines indicate that no altitude is coded for the procedure.